So we'll go ahead. I just want to make sure we're comfortable. I have 4 examples I thought of, and if we get to the point where you think they're way too easy, then we can just stop. So here I'm going to say f of x is x plus 5, g of x is 3x minus 11, and we want to find f divided by g of x. So my thought was, when I made the video, you guys have learned what this type of notation means before, what it means to add 2 functions together or subtract them or multiply them or divide them, that's something you're familiar with. And so today the hardest part would be the domain. Was that an accurate assumption of what you guys have? Okay. So the first step when you approach a problem is to ignore the operation to begin with and focus on the 2 different functions and find their domain. So this function is linear. It has a slope of 1 and a y-intercept of 5. It is not rational. It is not radical. It is not logarithmic. So what's the domain of this one? All real numbers. Does that make sense? Because it's not any of the things that we learned about yesterday that gives us an issue. So linear, all real numbers. You can plug anything you want. You can take any number you can possibly think of and add 5 to it. That's not a problem. You can always add 5 to something. Okay. The next one is also linear. It has a slope of 3 and a y-intercept of negative 11. It's not radical. It's not rational. It's not logarithmic. So what's the domain for that one? All real numbers. So before we start the problem, we're going to say, I'm assuming that the domain is all real numbers based on the information I have right now. Does that make sense, my assumption? Okay, so I'm guessing that's what it is. I'm going to go ahead and do the operation, and then after that, I'm going to ask myself if that answer tells me to exclude something. And if it does, I'll add it to my answer. Okay, so if we do f divided by g, what do we get? So x plus 5 over 3x minus 11. That's it. That's our first answer. Because they do want us to do the operation, so we have to show that we did that. Then we have to do the domain. So we predicted that the domain would be all real numbers. Is there anything else that this result tells us we should exclude? Yeah, the 3x minus 11 we have to look at because this is a rational expression. So what do we do when it's rational and we have a denominator? We want to see what would make the denominator equal 0. So I'm going to say 3x minus 11 is not allowed to equal 0. So that means our prediction was a little bit off. It's mostly true that you can have all numbers, but we are going to have to exclude something because of our answer. So 3x minus 11 can't equal 0, then what should we do? Plus the 11, so 3x cannot equal 11. And then what should we do? So x cannot equal 11 thirds. So you can write all real numbers, but skip 11 thirds, if you like that notation. Or you could say negative infinity to 11 thirds to infinity. Or you could say x is smaller than 11 thirds or bigger than 11 thirds. However you want to write it is fine. Okay. So when we write the domain of the original 2 functions, we're making our prediction. And then we just have to double check our prediction and make sure it was okay. All right, second example. We're going to do f of x is log base 3 of x plus 2, and g of x is ln of x of negative x minus 1, and we want to find f plus g of x. So we want to find the domains first of the original two functions. So what do we do for f of x?
Greater than or equal to?
Can it equal 0?
No.
Okay, so we're going to say x plus 2 is greater than 0. So what does that give us? X is greater than negative 2. Okay, so that's part of our domain. And then what do we do for this other one? Yeah, same thing. So an ln is still a log. It just looks a little different. And we say negative x minus 1 is greater than 0. And then what do we do? Say it again. Add 1. So negative x is greater than 1. Divide by negative 1, x and negative 1. And what happens to the symbol when you divide by a negative? You change it, you switch it. Okay, so we said that x is bigger than negative 2, but smaller than negative 1. That's our prediction right now. Okay, so our prediction is x is greater than negative 2, but smaller than negative 1. That narrows it down considerably, right? There's not a lot, there's only the decimals in between there that would make that true. Okay, so the operation that we're doing is we're finding f plus g of x. We're adding them together, okay? So I'm going to go ahead and just say that this equals log base 3 of x plus 2 plus ln of negative x minus 1, and that is all that I can do with it. You can't simplify logs that are not the same. So a log base 3 and an ln is technically a log with a base of e, so since their bases are different, we can't do anything with them. So if that's what we have, is there a reason? We know for sure that our domain, our prediction for our domain was that x is greater than negative 2, x is less than negative 1. Is there any reason this would tell us that we should exclude something else? No, it didn't make a fraction, right? It didn't introduce a new square root. It didn't add any more logs or anything, so that means that we're done. Our domain was good when we started with it. So now we just have to figure out how to write that you're bigger than negative 2, less than negative 1. How should we write that? So I heard somebody say negative 2, negative 1, but I need a little bit more. Parentheses. So if it's bigger than negative 2 but smaller than negative 1, then that means the only answers must be between negative 2 and negative 1. That's it. That's the only ones that work. And then we did parentheses because you can't equal them since they were both logs. Okay. If you struggle with these, I understand. It took me a really long time to get these. I definitely didn't understand them the first day I learned them. I was confused for a long time. So if you need to ask questions, if you need me to re-explain, I can do that. Okay? Don't feel like you have to get it in the first 10 minutes. Okay, let's do another one. So we're going to say f of x is x plus 5 over x minus 2. G of x is x minus 2 over x plus 5. And we are going to multiply these two together for the operation. So if we look at just the first one, we have x plus 5 over x minus 2. What would the domain be? X cannot equal 2. Okay? The other one is x minus 2 over x plus 5. Okay, so our prediction is everything except for 2 and negative 5. So our final answer, at the very least, our final answer has to be all real numbers, but not 2, not negative 5. We have to include that. Okay? So now we'll go ahead and do the problem and see if we should include anything else that needs to be gotten rid of. Okay, maybe we need to get a number out of there. So I'm going to say f times g would be x plus 5 over x minus 2 times x minus 2 over x plus 5. And this should bring back some fun memories of rational. Does it bring back any fun memories? No. Do you guys remember what to do with multiplication problems? You multiply straight across, but before you do that, you see if anything could cancel.
Oh.
And what do you see? Yeah, x minus 2 divided by x minus 2 cancels out to make a 1. And x plus 5 divided by x plus 5 cancels out to make a 1. And so the result of our operation is we have a function that just equals 1. That means we have a horizontal line. This would be a perfect horizontal line if we graphed it. Just 1. Okay. What would the domain be? So this would make us think it's all real numbers, but what did we say before we got here? Exclude 2, exclude negative 5. So even if it feels like we should be able to use all the x values, we can't because the original problem told us this. So at the very least, we have to exclude 2 and negative 5. Maybe we exclude more if this tells us to, but it didn't tell us to exclude more. We just got to keep excluding the 2 and the negative 5. Okay? So domain, all real numbers, skip negative 5, skip 2. Or we could also write it as negative infinity to negative 5, negative 5 to 2, 2 to infinity. So 2 different ways of writing the same thing. If you wanted to write it with inequality symbols, you could. I just don't usually in this situation because it's complicated. Okay. Do you guys want to do another example or do you want to start your assignment? One more? Okay. All right, so this one we'll say f of x is the square root of x, and we'll say g of x is the square root of x minus 5. And for this one, we're going to multiply f times g. So what do we do first? Yeah, so we have this one is x is greater than or equal to 0. This one is x minus 5 is greater than or equal to 0. So the top one's done. What do we do with this one? So x is greater than or equal to 5. So of the two of these, which one wins? Which one's more exclusive? The 5. Okay, so I'm going to ignore these, and I'm just going to say we are predicting that our domain is x is greater than or equal to 5. That's what we're predicting. Okay. All right, so let's look at this problem. If we multiply these, we're going to say we have the square root of x multiplied by the square root of x minus 5, and that means we have to remember how to multiply square roots. Do you guys remember how to do that? So what if I had square root 2 times square root 5? You multiply them. That would be square root 10. Okay? Because you just multiply the numbers underneath. So if we're doing this one, we're doing square root x times square root x minus 5. We're going to say that that is square root of, and we're going to multiply those together. Wait. X times x? X squared. X squared minus 5x. Okay, so there is our operation right there. And now we have to do just a little bit more, oops, sorry. We have to do a little bit more math to see if the domain that we predicted in the beginning is the right answer, or if this tells us to exclude even more from it. Okay? So if we look right there, how do we handle radicals that have quadratics inside of them. I put this one on there to help you guys review from yesterday. So we know it's a radical. What do we know about radicals? The stuff underneath the radical is greater than or equal to 0. So I'm going to write x squared minus 5x is greater than or equal to 0, right? And then it's a quadratic, so we have to factor it, right? And what do I get when I factor it? GCF, take out the GCF of x minus 5. And do you remember what you have to do if you have two x's with an inequality? The number line. You have to do the sign chart. Remember that? So we have to draw the number line. What are the two numbers on the number line? 5 and 0. Can we equal 5 and 0? Yes, because it says equal to 0. So you can equal them. You can equal 5. You can equal 0. And then what do we do with all these numbers? We've got 0 on the lower end. And I've got to check this section over here. So I pick a number smaller than 0. -1 we could pick. So if we do -1, we have -1, which is a negative. -1 minus 5 is a negative. A negative times a negative, positive. And then what's the number between 0 and 5? 1. 1 would work. So 1 is positive. 1 minus 5 is negative. A positive times a negative is negative. And then over here, a number bigger than 5, 6. 6 is positive. 6 minus 5, positive. And a positive times a positive is positive. Okay, so according to our sign chart, the answers that are bigger than 0 are anything up to 0 and anything bigger than 6. All right, so based on what we learned yesterday, this final answer looks like the domain should be everything smaller than 0, everything bigger than 5. Sorry, not 6, 5. Now look at the original problem. We said that we were predicting our domain was x is greater than or equal to 5, and we could exclude more from that, but we couldn't include more numbers than we had here. Okay? Does this one over here exclude more, or does it have more possible answers? It's part of it's the same, right? Because this one says 5 or bigger. This one says 0 or smaller. Can we start adding numbers back in? We can't add numbers back in. We can take more numbers out, but we can't start adding numbers back in. So that means that this answer right here was more limited than our end result, and so this is the one we have to keep. Okay? You keep the one that is more limited. At the very end, if you need to limit it further, you can, but you can't take an answer that includes more and use that instead. Okay? The way I like to think of this is like, if I look at this problem, this is like saying I'm having a dinner party and this represents a group of people who are gluten-free. And let's say within that, actually I'm going to do a different example. Let's say this represents people who are vegetarian. And let's say that this represents people who are vegan, right? Backwards. I'm making a mess of this. This works sometimes. Okay, let's say that this right here is vegetarian, this right here is vegan. So if you are making a meal for your friends, and some of them are vegetarian, and you have some friends who are vegan, then you're going to cook vegan for all of them because even the vegetarians are going to be happy. Does that make sense? Mm-hmm. Okay. This is kind of like saying I am making a vegan meal and I invited some meat eaters to my party, so I'm going to make some meat. Does that make sense?
Yes.
No, you're gonna still make the meal vegan because
No,
then
I'm saying-
everyone can eat it. You're saying my analogy makes sense,
yeah.
okay? So that's what we're saying is once we say that some people are vegan, that's the most exclusive thing you can possibly make at your party, you're gonna go all vegan. You're not gonna start adding other ingredients in there because you want to make sure that everyone can take part. That's what this is saying too, is if we know that we need to be this exclusive, we can't just go back and start adding numbers back in, okay? And that's because our original answer was more exclusive than the rest. So for this one, there is your final answer for your operation. And then our conclusion about our domain, I'm just going to put a box around this, is this one, x is greater than or equal to 5. Or if you wanted to write it in the other notation, you could say 5 with a bracket on it, comma, infinity. So these are basically like a 3-part process. The first part is to check your original 2 functions and write their domain. The second part is to actually do the operation. And then the third part is to check that and see if you should exclude more or if you should just keep your original prediction. Okay, 3 parts. All right, so look at your worksheet. Are there any problems on that first part of the worksheet? We're just looking at the front side right now. Are there any problems on there that we feel like we might be confused on, need to look at together?
7.
7? Okay. All right, so for number 7, if we find the domain separately, if we find the domain of each part separately, what do we see? Radical. Okay, so this one, the stuff that's underneath the radical is greater than or equal to 0. The stuff that's underneath the radical is greater than or equal to 0. So what's our prediction right now? Greater than or equal to 0. That's what we're expecting. Okay, so now we'll go ahead and do the multiplication. So we're going to do square root of x times 2 square root of x. And when we multiply those two together, what do we get? Yeah, so we do x times x is x squared. Can you simplify that? 2x, yeah. The squared and the square root cancel, right? So we get 2x. So we've completed the operation. Now we have to say, I predicted that the domain would be not all real numbers. I predicted that the domain would be anything greater than or equal to 0. Does this answer tell me that I should exclude something else? No. So I'm going to say my domain is x is greater than or equal to 0, or I can write 0 to infinity. Whichever way you want to write it is fine. Now, it's important for you to do this first step because most students would try to tell me this was all real numbers. And then they would get it wrong, okay? And one of the ways you can kind of check yourself is if you type in the problem, the original problem that you did before you simplify it. So if I was to type in square root of x times 2 square root of x and graph it, you'll see that it is the line 2x, but it's only the right side of the line. Does that make sense? So that's a good way for me to check my answer because the graph won't lie to me. I can see it in the graph, okay? And the graph is telling me definitely I should be skipping all these negative numbers. They didn't work, okay? And then if I want to check to see if it should be a bracket or not, I can do second trace and value lets me plug in x values. If I plug in 0, I get an answer. And that's how I know that 0 is allowed to happen. If I try to plug in -1, I do not get an answer, and that's how I know it's outside of the domain. Okay? So if you want to use a calculator and graph some of these, you graph it before you simplify, and that can help you check some of your answers if you want to. All right? Go ahead on your worksheet. What I'm going to say is scribble out this part. Oh, sorry, it's frozen. Sorry. There you go. Okay. On your worksheet, what I was originally asking you to do was find f of g of x. So take g and plug it into f. And then I said also take f and plug it into g, so that would mean you did every single problem twice. But I'm just going to say you could just do f of g of x. For those of you who already started, it's fine if you did the opposite version because my answer key has both of them, so you can still check your answer. Okay, so really I just want you to get some practice, but on here I was like, maybe I don't need to make you do every single problem both ways. Okay, so what I'm going to do is we can pick a couple of these and I will do the alternate version you don't have to do for homework. Okay, all right. So on another sheet of paper, if you look at these, is there a problem in particular that would make you nervous? Number 14. Okay. So if we look at number 14, it says f of x is x to the third plus 4, and it says g of x is x minus 4 to the 1/3. And I would not write this on the worksheet itself because you're going to have to do the other version yourself. So I would write it on a separate sheet of paper so you're leaving yourself some space. So on your worksheet, you're going to do f of g of x. That means for an example, we are going to do g of f of x. Okay. All right. So one thing I specified when we talk about these functions is I said that for composition only, whenever you're doing this where you're taking one function and plugging it into another one, you don't care about the domain of both of them. You only care about the domain of the inside. And that's because domain literally means what inputs work. What numbers can you plug in, and it actually gives you an answer. Okay? So since f of x is what we're going to plug in, then we only care about what works for f of x. Okay? So if you look at f of x, that's a cubic, x to the third plus 4. It is not a radical, it's not rational, it's not logarithmic. So what do we know about the domain? All real numbers. Okay? Just for future reference for this to help you for tonight, what's an exponent of 1/3 mean? A cube root, yeah. So this is actually the cube root of x minus 4. Sometimes it helps to write it that way instead. Maybe a little bit easier for your brain to think about. Remember when we talked about radical, it's only a square root or a fourth root or a sixth root that has the issue with negatives. You can take the third root of a negative and it works just fine. So if I asked you to give me the third root of -8, I would say, what multiplies by itself 3 times to give you -8? And that's -2. -2 times -2 times -2 is -8. So when you're doing this one tonight and you have to find the domain of g of x, it's still going to be all real numbers because it's an odd root, not an even root. The even roots are the ones that are the issue, which is why for every single problem we did square roots, because those are the hard ones. Okay? All right. So for this one it says take g and plug f of x into it. So we're going to start with g, and I'm going to write third root of x minus 4. And then the thing that I'm plugging into x is the other function, which is x to the third plus 4. All right, so if I simplify this, these parentheses aren't really necessary. I just drew them so I knew where to plug stuff in. So what do you guys see? Yeah, the 4's cancel. We have the third root of x to the third, which will cancel, and you just get x. So your composition gives you x. We predicted our domain would be all real numbers. What did our answer tell us? All real numbers. It confirmed it. Our prediction was good. Okay, we only have 2 minutes, but I'm going to try to do this one real fast because it's one that throws students off a lot. So if I said f of x is x squared, and g of x is the square root of x, and I wanted to find f of g of x. Don't pack up yet. Don't pack up yet. You're going to want to see this. It will help you for tonight. So the one that we care about is the one we're plugging into something else, and that's the g of x. So we know the domain there is x is greater than or equal to 0, right? And when we do our composition, we're going to say something squared. That's what we're doing, right? And the one that we're plugging in is the square root of x. So what happens when you square the square root of x? You just get x. Now it seems like the domain should be all real numbers, but what's the domain actually? Greater than or equal to 0, because that's what we predicted originally. Okay? That's a favorite for composition problems, so watch out for that one. Okay? All right, what do you do tonight if you get stuck? Text me and I'll talk you through it. Okay, so if you get stuck on a problem, take a picture of the problem, send me the picture and say help. Okay? And I can work with that. I'll work with that.